Hello everyone, welcome back to the Right Ride, where we're building a game without a game engine. And today we're gonna do one or two things. Create an arena around our whatever it is. So let's get started. So we're back with our code, and let's just do one thing. Let's run it and see what we have done so far. So our paddles are moving, and yeah, now what we have to do is create an arena. And why we want to create an arena is like if you see, so this is our ball and it's moving in this direction, and if you see, this is very big kind of a gap over here. And for example, if it's moving like in a diagonal direction upwards, like if you see my mouse pointer, so what would happen if it comes here? It should bounce back, right? Because this is not where we want the ball to go. So so what we need to do here is create some kind of a barrier. And how do we identify that barrier is I don't know, maybe let's put up some pixels over here. So what am I going to do is I'm just going to cover this line, the top line, the bottom line, with some character. I don't know what, but just gonna cover this, and maybe some part of this I'll just see what looks better when I convert it. So should print pixel. What have we done here is that, okay, if it's a paddle, if it's the ball, then we're printing the pixels. We're not printing the pixel. Now let's change this method a little bit. So instead of should print, this would give us what pixel we want to print. So I'm gonna simply rename it as get pixel to print. Okay, just like replace it everywhere wherever it is. We're done, and instead of int, I'll simply return a character. So now if it's a paddle, we want to print star. Okay, or maybe let's just go with O, because this looks more like a ball than balls. Okay, and if there's nothing, then this simply blank space. And now one more thing which we want to print is the boundary. So let's make it as hash. If I'm gonna say boundary x and y, we're gonna return a hash. Okay, now this is not defined. We have to define it. Int, and we have to define this function here, int boundary, or let's just rename it something like, is boundary. Okay, now we have to take x and y. So for now, let's just return 0 because we don't have a boundary, and get pixel to print should be, I don't know what arguments you need to give to this. I'm just gonna give a %c. I don't know what happens with this. No, I really don't know what happens with %c. %c prints the character. That is good to know. Okay, now moving to boundary, top line. So on the top line, if you see, the y factor is 0, and at the bottom the y is 29. So if we're gonna do simply if y equal to 0 or y equal to 29, return 1, return 0. Let's see what happens. Cool, so top and bottom boundaries are here. Now this space also looks quite large, so that so let's make a very small goal. Now if you're making a goal and we're making a boundary, then the paddles would shift inwards by 1 pixel, and if you see, the goal should be big enough so that it gets covered by the paddles, and not so big that it's very hard to do this. And okay, and we have to essentially cover this overlap as well. So I think 7, 1, 2, 3, 4, 5, 6, 7 from top, 7 from bottom. That's cool. That's the only amount of boundaries we need. So okay, in this case we have to return 1, and if y is greater than equal to 1 and y is less than equal to, how many pixels should we cover? 1 to 7, right? So 7 from top, 7 from bottom. That's 14 to 16, and the 14 pixel goal is remaining. I think that's fine. Okay, if it's the top or if it's the bottom. What's the bottom? Bottom is less than equal to 29, and y is greater than equal to, and there we go. So 2, 3, 4, 5, 6, 7, 7 here, and this is the goal. Now we have to shoot the paddle inwards. So paddle, the x of the paddle this, and paddle 2's x will be this. And now the paddles have shifted inwards. So this is the starting position, and init paddles. So it should be greater than 1. And 24, 1, 24 is the starting position. So now this should not interfere. Okay, now I'm going all the way down, and now I'm gonna press 5, it's not going down, and when I'm going up, it's not going up. So there, we have our paddles. Okay, here and here. I was just checking with the right paddle. The left one would do the same thing because we have made the same modifications. I'm just gonna add some function to the ball now. So boundaries there, paddle is there, and the ball is ball. So we're gonna give it an x and y, and now we have to define this function first. I did copy it. Okay, int y. So here, if you see, what we can do is simply would have copy the code. But what we're gonna do, we made the paddles as a structure, so we're gonna make a ball as a structure. Struct ball. Now, let's just define a b ball kind of thing. So ball would have obviously int x and int y coordinates there. And is there anything else with the ball will have? So the ball needs to move in a certain direction, and in raster graphics, if you want to create a line, there are multiple methods to do that. We're gonna what we're gonna do is we're gonna create a simple mathematical model over here, and that model would say, we're gonna first of all just define some values. So like if let's say angle. So we're gonna have very discrete values of angles here. And the next thing is increment in x and increment in like the probable increment in y. So if the angle is 0 degree, that like it's a horizontal line, so x would either increase or decrease by like infinite times, and y won't change. And if the angle is, let's say, 90 degrees, the x won't change at all, and y would change how many times? It's gonna change infinite. It can change infinite times, but let's just say if it's 30 degrees, so how many pixels we want x to increment once we increment a y pixel. So how much x do we want to increment when we increment y? It's 30 is like 1/3 of the way between 0 to 90. So I'm gonna increment 3 x's before I increment a y. 45, I'm just gonna give it a 1 and 1. And for 60, we're gonna give 1 to this and 3 to this, because that's like kind of the opposite. That's the kind of the table we have, and instead of infinity, we should probably define a value. So if it's -1, it's infinity, and -1 is infinity. And now we want to know the angle of incidence and angle of reflection, so that we know in what direction do we want to send the ball. This is kind of very basic. Now we have to convert this problem into code. We already have a solution basically. So if it's a ball, for now let's just return 0, and if x equal to y equal to 15, turn 1. So there is it. Now let's just say in the beginning the angle of travel is 0 and it's traveling horizontally somewhere, and once it reaches there, what we will do is to, I don't know, make the game interesting, or I don't know what, but we're going to determine a random angle between 60, 30 and 45, so that it either goes like very slowly downwards or very slowly upwards, very fast upwards or very fast downwards. So I think we need two things. Angle is obviously the angle and the direction, up or down. So that's one thing. So that, like, there's two things we need: angle and the direction. And that is only when we hit this paddle. And when we hit the wall, we're just gonna reverse whatever it is. So when we hit the wall, let's say we have hit the wall and its angle is 30 degrees up, so it's gonna go 30 degrees down, just gonna reverse the direction. And here what we're gonna do is we're gonna reverse the direction of the reverse the direction horizontally, and here we're gonna reverse the direction vertically. Okay, so that's the travel plans. Cool. Those are the travel plans. So current coordinates, we have current horizontal direction, we're gonna have current vertical direction, we're gonna have angle what? Angle increment relationship. No, I'm not in office. Angle IR. That's fine. So I'm gonna have 0. I'm gonna have 30, 30, it's 30. Okay, and here what we're gonna have is int incx and int incy. This we will define, b we will have to define, and we have to define what? We have to define b, we have to define these angles, we have to define. Cool, so I think I have to shift this upwards because, you know, I'll say that structure is not defined if I do this. So what have we done so far? We have created a mathematical model of how our ball will travel and some logic in, and we've put some logic in it, and now we're going to code it. So now we are going to code it, and you know what? I'm tired. I'm just tired. I'm gonna come back. So I think that's all for today. You know what? It's very hot in here, and I've turned off the fan because my mic keeps up picking that static. That's very annoying, and my voice doesn't even go through to the mic, and that's why I've just turned off the fan. And it's like been more than 25 minutes, so I'm like, so I'm gonna continue everything in the next video. See you then.